Head-on collision. What happens in head-on collision? Look here. We have an object of mass m1. It is moving with velocity u1. Another object of mass m2. It is moving with initial velocity of u2. Now, this information is before collision. Before collision, m1 is moving with u1, m2 is moving with u2. Our aim is to find their velocities after the collision. This m1 and m2, after collision their velocities are v1 and v2, and our aim is to find these velocities. Now, this is before, this is after collision. What happens during collision? Let's look at this part. When these two objects, they are undergoing this collision, they are in contact with each other, m1 and m2. This setup is during the collision. What is happening during collision? Let's draw its free body diagram. Free body diagram of this collision. When you draw it, that's your m1, this is your m2. Remember, they are touching each other, but we are drawing what? Free body diagrams. This is m1, this is m2. This surface is what? Contact surface. This is the contact surface, and we know that normal reaction force acts perpendicular to the contact surface and towards the body. This is normal reaction N. This is the contact surface. Normal reaction force acts normal to the contact surface and towards the body. This is N. If this is action, then this is reaction. They both are equal but opposite. This is the situation during collision. This m1 was moving with u1 before impact, but due to this normal reaction N, its velocity changes from u1 to v1. This m2 was moving with some initial velocity of u2, and because of this normal reaction force, its velocity changes from u2 to v2. That's what is happening during collision. So this is the free body diagram, and as you know that this impact duration, when two things collide, this duration you can say is simply what? dt. This whole thing is over, this whole collision part is over in time dt. In dt time, velocity changes from u1 to v1. In dt time, velocity changes from u2 to V2. Our aim is to find V1 and V2. Now, what are the things which are available to us so that we can calculate V1 and V2? Let's focus on those things. First thing you can see is, if you look at M1, a force is present. Similarly, if you look at M2, a force is present. And therefore, linear momentum of M1 will change. Similarly, linear momentum of M2 will also change. But if you look at M1 and M2 both as a system, M1 and M2 both as a system, then there are no external forces. कोई बाहर से कुछ पुश नहीं कर रहा है. Whatever is happening is all internal. Action and reaction, you know, they are called what? Internal forces when you take the whole thing together, which means on the system of M1 and M2, on the system of M1 and M2, F external is 0. F external is what? 0. And now we know that if F external is 0, there is no external force. If there is no external force, I hope you remember this. COLM. What is COLM? Conservation of linear momentum. Conservation of linear momentum. COLM. F. What is F? dP by dt. If F is 0, then dP is 0. dP means what? Change in linear momentum is 0. If change is 0, that means linear momentum is what? Conserved. But remember, you cannot conserve linear momentum of M1. Force is present. You cannot conserve linear momentum of M2. Force is present. In fact, write down the statement. We cannot conserve linear momentum of M1 or M2 when they are considered separately. As normal reaction force is present in the form of an external force. As normal reaction force is present in the form of external force. But when both M1 and M2 are taken together, as a system, we can conserve linear momentum of the system. As same normal reaction force now behaves as an internal force. Inside bracket, action and reaction forces. Now, once you say that COLM can be applied, let's write down initial linear momentum P initial and then P final. Look at this vector sign. Linear momentum is a vector quantity. I have shown you that this is moving in this direction, this is moving in this direction. But in any example, you can have velocities in any particular direction. That will be taken care of by this vector sign. Now, what is initial linear momentum? M1 is moving with U1, M2 is moving with U2. Before M1 is moving with U1, M2 is moving with U2. This is M1 U1 plus M2 U2. And finally M1 moves with V1 and M2 moves with V2. This gives us first equation for head-on collision, which is coming from conservation of linear momentum. But if you look at this equation, there are two unknowns, V1 and V2, and this is the single equation. And you know that for two unknowns, you must have two separate equations. And this second equation comes from Newton again. Now what Newton found? Newton's impact equation. Now what Newton found that if you take relative velocities after collision and you take relative velocities before collision and you go for the ratio, he found that for a given set of object, this ratio was a constant. What is relative velocity after collision? Relative velocity after collision is V2 minus V1. Relative velocity before collision, U2 minus U1. What he found is that this ratio is a constant and is called minus of E. Basically ratio is E, negative sign का जो logic है अभी समझेंगे अपन. This E is called coefficient of restitution. Coefficient of restitution. Ratio of relative velocities after with that before is a constant. Now let's understand the meaning of negative sign with the help of this particular example. Now if you look at this setup, in this, for collision to happen, U1 should be greater than U2. This M2 is ahead of M1 and therefore for collision to take place, U1 should be greater than U2. Which means, look at the denominator. If you say that U1 is greater than U2, then this denominator is what? Negative. And after collision, I hope you can feel it, that velocity of M2 should be greater than M1. इसको फास्ट चलना पड़ेगा collision के बाद, collision के पहले इसको फास्ट चलना पड़ेगा, and therefore after collision V2 is greater than V1. This numerator is what? Positive. Denominator is what? Negative. And therefore you are getting a negative sign. Otherwise, if you simply say that magnitude of relative velocities before and after, if you take the ratio, that ratio is what? A constant, which is called coefficient of restitution, which is a constant for a given set of objects. For this N1 and M2, you can change U1, you can change U2, but E, coefficient of restitution, will remain what? Same. Write down this second equation, and before that look here, again we are dealing with what? Vector quantities. V2, V1, U2, U1. These are all what? Vectors. E, coefficient of restitution, has given us second equation. Now there are two unknowns, V1 and V2, and we have got two equations. Any question of head-on collision can be solved with the help of these two equations. Any question of head-on collision can be solved with the help of these two equations. Write down this second equation as a statement. से ये आपको याद है पूरी कहानी क्या थी. Write down this Newton's impact equation. According to Newton, ratio of relative velocities after collision with that before collision is a constant for a given set of objects. This constant is called coefficient of restitution. This constant is called coefficient of restitution. Inside the bracket E. Next line. For perfectly elastic collisions, E is 1. For perfectly elastic collisions, E is 1. Now what's the meaning of E equals to 1? Remember this. When you say perfectly elastic collision, it means no loss of energy takes place. Write down this. Perfectly elastic collision means no loss of energy takes place. No loss of energy takes place. That's called perfectly elastic collision. Write down next line. For perfectly inelastic collisions, E is 0. For perfectly inelastic collisions, E is 0. After a perfectly inelastic collision, both bodies move together. After a perfectly inelastic collision, both bodies move together. That is V1 is equal to V2. That is V1 is equal to V2. And this is something which is coming from the equation itself. If you put E equals to 0, if your E is 0, then V2 minus V1 is becoming what? 0, giving you what? V1 equals to V2. And because of this we say that this E lies between 1 and 0. Perfectly inelastic collision. During perfectly elastic collision, no loss of energy takes place. After perfectly inelastic collision, both bodies move together. Now you know that things are never perfect, and therefore E equals to 1 and E equals to 0. They are theoretical cases. हालांकि अपन उनको कंसीडर करते हैं. बाकी रियल लाइफ में you will find that things are less than 1 and greater than 0. केवल E1 में एनर्जी लॉस नहीं होता है, बाकी सारे केसेस में एनर्जी का क्या होगा? लॉस होगा. एंड वी विल सी सम एग्जांपल्स लेटर जिससे कि ये चीजें और भी अपने को क्लियर हो जाएं. Note down this much and then we will see some examples on head-on collision. Now let's see how to use these two equations for head-on collision. And we'll start this question with a spatial profile, and it will be a good result for you to remember. This is M1, this is M2. Suppose M1 is moving in this direction with 4 meters per second, and M2 is moving in this direction with 3 meters per second. And both M1 and M2, they are of equal mass. M1 is what? M2. The masses are what? Same. And coefficient of restitution between these two, M1 and M2, is what? 1. It's a perfectly elastic collision. And remember, at times they will simply give you elastic collision. If they give you elastic collision, that means E is what? 1. They do not mention many times perfectly elastic. They simply say elastic collision. And if they say that E is this and that, then definitely use that. Now, let's use first equation, which is M1U1 plus M2U2 equals to M1V1 plus M2V2. How do we use this equation? M1 is M, U1 is 4, M2 is M, U2, remember, is not 3. U2 is what? Minus 3, because of it being left. Then M1V1 plus M2V2, M1 is M, M2V2. Now V1 and V2 are unknown. We have no idea where this M2 is going. Unknown things are used without any sign, and therefore we are simply writing V1 and V2. If when you calculate the whole thing, V1 comes positive, that means it's moving in this direction. V2 comes positive, that means it's moving in this direction. If these V1 and V2, if they come negative, that means they're not moving in this direction. Instead, they're moving the opposite direction. This gives you equation number 1. M1U1 plus M2U2 equals to M1V1 plus M2V2. Known quantities, use them with proper sign. Unknown quantities, use them without any sign. Now this equation is M cancel. You can see that this thing gives us V1 plus V2 equals to 4 minus 3, which is coming 1. 4 minus 3 is what? 1. Now let's use the second equation. Second equation is V2 minus V1 upon U2 minus of 3 minus U1 4 is what? Minus of E, which is for perfectly elastic collision is 1. This gives us V2 minus V1. V2 minus V1 as minus 7 minus plus is coming what? 7. These two equations, they give us these two final formats. Now how to solve these equations you already know. Let's add these equations first. V1 and V1, they are cancelled. V2 plus V2, it gives us 2V2. 7 plus 1, 8. From this we got V2 as 4 meters per second. V2 is coming 8 upon 2, that is 4 meters per second. Now let's find out V1. Let's use this equation. V1 is 1 minus V2. And what's the value of V2? 4. This is 1 minus 4, which is coming minus of 3 meters per second. What's the meaning of plus 4 and minus 3? This is before. The thing which you see is before collision. Now after collision, what happens? Look here. After collision, M1 and M2, they're moving like this. M2, its velocity is what? 4. That is plus 4. It's moving in this direction with 4 meters per second. Velocity of M1 is minus 3. Minus means this M1 is moving in this direction with 3 meters per second. Look at the important part. I said it's an important profile. M1 was moving with 4. Now M2 is moving with 4. M2 was moving with 3 in this direction. Now M1 is moving in this direction with 3 meters per second. Which means what happened when two objects collide such that their masses are same and collision is what? Perfectly elastic. Then they simply interchange their velocities. Velocity of M1 is taken by M2 and velocity of M2 is taken by M1. Note down this and then write down the statement. When a head-on collision takes place, between two identical objects, such that this collision is perfectly elastic, then after the collision, objects simply interchange their velocities. You need to remember two things. Collision should be perfectly elastic and they should have identical masses. Then only you say that things they interchange. Velocities are interchanged. Note down this example. Let's take another example. And it's also a result type question. There are two objects, M1 and M2. Head-on collision which is perfectly elastic. M1 is of 5 kg and it's moving in this direction with 2 meters per second. M2 is 10 kg and it's moving in this direction with 1 meter per second. You cannot use concept of last question because masses are not equal. This is 5 and this is what? 10. Now see what happens. Now before I start, pause the video, try to answer using these two equations, equation number 1 and equation number 2, find out velocities after collision. It should not take more than 2 minutes. Now, look at the first equation, M1 U1. M1 is what? 5. U1 is 2. M2 is 10. U2 is not 1, is what? Minus 1. Equals to M1 V1, 5 V1 plus 10 V2. Same thing, known quantities with proper sign, unknown quantities without any sign. So this equation is ultimately 5 V1 plus 10 V2. 5 V1 plus 10 V2, which is coming 5 into 2, 10 minus 10. That is what? 0. Let's use second equation. Second equation says V2 minus V1 upon U2 minus of 1 U1 minus of 2 U2 minus U1 is minus E. This thing becomes V2 minus V1, V2 minus V1 equals to what? 3. This first equation you can simplify it and it gives you V1 plus 2V2 equals to 0. 5, 10, 2 is 0. Now this is your second equation. This is simplified first equation. Add these two equations. When you add these two equations, V1 and V1 they are cancelled. V2 plus 2V2, it gives you 3V2. V2 plus 2V2, it gives you 3V2. 3 plus 0 is what? 3. V2 is coming 1. That's V2. I put this V2 in this equation. That will give you what? V1. V1 is minus of 2V2. V1 is minus of 2V2, which is minus of 2. V2 we have already calculated 1. It becomes minus 2 meters per second. 1 meter per second. Now hopefully you can see the result which we have obtained. This M1 was moving in this direction with 2 meters per second. Now velocity of M1 after collision is what? V1 is what? Minus 2. That means after collision M1 is moving in this direction with same magnitude, 2 meters per second. Look at 10 kg. Before collision it was moving with 1 left, but after collision it's moving with 1, it's plus 1, that means the right direction. This is the velocity 1 meter per second. Now if in school they ask you this question, follow equation number 1 and equation number 2. In competitive examinations, if they ask you this question, or in any objective profile they ask you this question, now look at the initial data which was given. 5 and 2. What is 5 into 2? 10. Look here. What is 10 into minus 1? Minus 10. What is happening? Initial linear momentum is what? 0. Whatever linear momentum is present with M1, 5 into 10. Negative of that is present with M2. 10 into 1. The masses are not equal, but their magnitudes of linear momentum are equal. And their linear momentas are in opposite direction. Linear momentas are in opposite direction. This and this. जब भी ऐसा होता है तो होता क्या है? What is this part? What is this part? Linear momentum. What is linear momentum? You can see 10 minus 10, 0. So if linear momentum of the system is 0, and a head-on elastic collision takes place, then these objects, they simply reverse their directions. It's moving with 2, it will move in the opposite direction. It's moving with 1, it will move in the opposite direction. That's how you can use these concepts, these things as direct results. Write down the statement. If a perfectly elastic head-on collision takes place, between two objects such that their linear momentums are of same magnitude but in opposite directions. Its linear momentum is 10. Its linear momentum is also 10 but is in this direction. Then after the collision, objects simply reverse their directions of motion. Objects simply reverse their directions of motion. Magnitudes of velocities, they do not change. Magnitudes of velocities, they do not change. इसके पहले वाले में क्या हुआ था, ध्यान रखना, इसके पहले वाले में मासेस इक्वल थे, वेलोसिटीज क्या हो गई थी, इंटरचेंज. अभी क्या हो रहा है, मासेस आर नॉट इक्वल. What is equal? Nothing is equal. Linear momentums, their magnitudes are equal only. Linear momentums are not same. This is positive linear momentum and this is negative linear momentum. But the linear momentums are in opposite direction, which gives us total linear momentum as what? 0. And when it happens, and collision is what? Perfectly elastic, we say what? Objects simply reverse their direction of motion. 2 becomes -2. 1, this -1 becomes 1. Magnitudes of individual velocities, they remain what? Same. Hopefully समझ में आ गया होगा. Or down this whole thing. Look at this next example. There are two objects of 5 kg and 4 kg. 5 and 4. This 5 kg is moving in this direction with 20 meters per second. And 4 kg, it's moving in this direction with 6 meters per second. Coefficient of restitution is what? 0. We need to find their velocities after collision. At the same time, we need to find how much energy is lost during the collision. Because of the collision, which is not perfectly elastic, you can see loss of energy will take place, and we need to find that loss of energy. Write down the question. Find out velocities of both blocks after perfectly inelastic collision, and also find out loss of energy during the collision, and also find out loss of energy during the collision. Pause the video, try to solve it, and then come back and see the solution. These are the two equations. If you need to find V1 and V2, इसके अलावा कुछ करना ही नहीं. M1 is 5, V1 is 20, M2 is 4, V1 is 6, M1, V1, M2, V2. This gives us 5v1 plus 4v2, 5v1 plus 4v2 as 100 plus 24, that is 124. That's your equation number 1. Second equation, v2 minus v1 upon u2 minus u1 minus of E, which is what? 0. Which is what? 0. If you remember, when we were discussing this thing perfectly inelastic, I have told you that after perfectly inelastic collision, both objects move together with same velocity. That's what this equation gives us. 6, this and all multiplied by 0 gives you ultimately what? V1 equals to V2. V1 equals to what? V2. V1 equals to V2, put this in this equation. So with the help of this and this, we get what? 5V1 plus 4V2, which is also V1, 124. That gives us 9V1 as 124, or V1 is coming 124 divided by 9 meters per second. And whatever is the value of V1, same is the value of V2. Because after collision, these two blocks, they move together. You can say that the whole mass of 9 kg, 5 and 4, the whole thing is moving in this direction with a velocity of 124 divided by 9 meters per second. They kind of stick together and move in this direction. This is after collision. This is before. That's how you can find V1 and V2. Next part is find out loss of energy. Now, when you talk about loss of energy, you can see that they are moving on a frictionless horizontal surface. If they are moving on a frictionless horizontal surface, then what happened? Initially kinetic energy of the system is what? Half m1 u1 square plus half m2 u2 square. m1 u1 m2 u2, everything is known, you can calculate this. Final kinetic energy, we have also calculated final kinetic energy, which is coming what? Half m1 v1 square plus half m2 v2 square. Or you can directly take 9 kg multiply by this. Since E is not 1, if E is not 1, then in every collision loss of energy will take place. Not for E0, for any collision where E is not 1. For E less than 1, loss in energy takes place. Loss in energy means initial kinetic energy will be definitely greater than what? Final kinetic energy. And therefore loss is also equivalent to what? Heat. Whatever loss in kinetic energy takes place, that appears in the form of what? Heat. Now, loss of what? Mechanical energy. And that loss of mechanical energy is basically appearing in the form of what? Heat. When you say mechanical energy, there are two energies, kinetic and potential. Now, look at this. Whenever collision takes place, just during the collision, there is hardly any change in the height, even if collision takes place on an inclined surface. Look here. So somebody says that two objects collide on an inclined surface. Now, on this inclined surface, when collision takes place, You know that that collision takes place only for what time? dt. When two things collide, the sound which is coming, that sound is coming only for what time? dt. In this dt time, there is hardly any change in the height of these objects, even if collision takes place on an inclined surface, even if collision takes place in vertical direction. If you drop this thing and if you throw this thing up and they collide and if I ask you what is loss of energy during the collision, that means you will always find difference of their kinetic energies, because during dt time, it's not something like this that collision started at this point and took place from this point to this point. No, it's an instantaneous process. And since it's an instantaneous process, there is hardly any change in the height. If there is no change in height, we do not go for potential energy change. That means whatever loss is happening, that loss is basically loss in kinetic energy only. You can call it loss in mechanical energy, but there is hardly any change in potential energy, and therefore loss is in the form of what? Loss is in the kinetic energy only, and this loss is coming out as what? Heat. How much heat? Kinetic energy initial minus kinetic energy final. You can calculate these values and then subtract and you will get the answer. Note down everything. Let's see collision between a light and a heavy object. Let's say there are two objects. One is M1, let's call it capital M, and M2, let's call it small m, such that M is much larger than M. It's a very heavy object as compared to this. And coefficient of restitution is what? E. It's moving in this direction with U1. It's moving in this direction with U2. And our aim is to find the velocities after collision. This is something like a truck is moving, kind of. A truck is moving. And on this moving truck, if you throw a ball. Now, on a moving truck, if you throw a ball, and then if I ask you what are the velocities of that truck and the ball, then I hope you can understand this, that V1 will be approximately U1 only. If you throw a ball on a moving truck, then that impact is not going to change velocity of the truck. And therefore we are saying that for a heavy and light object collision, velocity of the heavier object, even after collision remains what? Same. Once you understand this part, we can directly use the Newton's equation, which is V2 minus V1 upon U2 minus U1 equals to minus E for the calculation of velocity of M2 after the collision. We need to find V2, and we are saying that V1 is nothing but U1. V1 is nothing but U1 divided by U2 minus U1 equals to what? Minus of E. This gives us V2 minus U1 as minus of EU2 plus EU1. Our aim is to find what? V2. Aim is to find V2, and this V2 is coming, minus of E times U2 move this U1 to that side, plus 1 plus E times U1. V2 is coming what? Minus of EU2 plus 1 plus E times U1. If you wish, you can remember this as a result. What is V2? What is 2 light object? What is 1 heavy object? What is V2? Velocity of light object after collision is coming what? Minus of EU2 plus 1 plus E times U1. Velocity of the heavier object that suffers no appreciable change and therefore remains what? Almost same. This is something which we are interested in when we write collision between heavy and light object. Now let me just give you a mathematical proof for V1 being equal to U1 using equation number 1. Although we don't need that because I simply said that it's a very heavy object, there's hardly any change in it. But if somebody is interested, then they can go for this. The first equation, which was based on conservation of linear momentum, says m1u1 plus m2u2 is equal to what? m1v1 plus m2v2. That's your equation number 1. Now what is m1? What is m1 capital M? This is capital M u1 small m u2 capital M v1 small m V2. इस तरह से हमने इस चीज को अरेंज किया. Then what we did, after you write this equation, divide each and every term with capital M. Divide each and every term with capital M. Now, why divide this whole thing with capital M? Look at this. If I ask you what is M upon M, and you will simply say what? 1. Capital M upon capital M. But if I ask you what is small m upon capital M, then I hope you understand that small m upon capital M is approximately what? 0. When capital M is much larger than what? Small m. It's like this. Suppose you say that capital M is 1000 kg. If capital M is 1000 kg and small m, even if it's 1 kg, then small m upon capital M, you can see is 1 upon 1000. It becomes such a small number which is 10 to the power minus 3. If I further decrease m, if I say it's only 1 gram, this thing will become what? 10 to the power minus 6. Again, closer to what? 0. Which means if capital M is much larger than small m, then this number is approximately what? 0. Capital M, they are cancelled, you get what? U1. Small m, capital M. Small m upon capital M is what? 0. Second term becomes what? 0. Capital M, cancel. This gives you V1 plus small m upon capital M, it becomes what? 0. That gives us V1 as U1. If you are looking for mathematical proof of this, right there, you can see it. Now, note down everything and then we'll start using examples on this concept. When you write this thing, remember, when I say V2 is velocity of the lighter object. 1 is velocity of the heavier object. And heavier object, इसके लिए बड़ा आसान है याद रखना, that heavier object's velocity does not change or hardly any change. तो अपने दिमाग में फिट रहेगा कि ये फॉर्मेट हैवी ऑब्जेक्ट के लिए नहीं हो सकता. किसके लिए होगा? लाइट वेट ऑब्जेक्ट के लिए. The moment you remember this, that V1 doesn't change, velocity of heavier object doesn't change, then remember this. If you don't want to remember this whole setup in this form, simply remember this. V2 minus V1 upon U2 minus U1 equals to minus E. जो भी heavier object है, 1, 2 कुछ भी हो, उसकी velocity को क्या कर दो आप? Same रखो. Wrote down everything. Now let's see a few examples on this. We have been given a truck. That's a truck. And this truck is moving in this direction with 20 meters per second. And a ball, if you throw this ball in this direction, with a speed of 5 meters per second, coefficient of restitution is 1, and the question is find out velocity of the ball after collision. We need to find velocity of the ball after collision. Nobody will ask you velocity of truck after collision. You know that will remain what? Same. Now, if I ask you velocity of the lighter object, either you can directly go for this equation, which we'll use later, but if you don't remember this whole part, then just remember where it came from. V2 minus V1 upon U2 minus U1 equals to minus E. You don't have to worry about 1 and 2. It's your wish. If you say this is 1, use it as 1. If your wish, you can use this thing as 1. And therefore there is hardly any use of this equation. Remember this. Now, 1 or 2, it's your wish. But velocity of this truck is not going to change. Suppose we say this is M1, we say this is M2. They will not give you masses also in this type of situation. It's a truck, it's a ball. They have already given you that. It's a type of collision between light and heavy objects. Now, V2, our aim is to find V2 minus V1. This truck is moving with what? 20. Divided by U2. U2 is, remember, it's not 5, it's what? Minus 5. Many a times people commit mistake only in this part, plus and minus part, which you take with these velocities. Minus of U1, truck moving with 20, coefficient of restitution is what? 1. This gives you V2 minus 20 as what? 25. Ultimately giving you V2 as 45 meters per second. That means this ball, after undergoing collision, moves in this direction with a velocity of 45 meters per second. It will be moving in this direction. Now, if somebody wants to use this result, if you remember this result, then you can go for it. Minus of E, U2 minus of 5 plus 1 plus E, U1, which is what? 20. You can see that 20, this is coming 40 plus 5, that's coming 45 meters per second. It's your wish. We can remember this minus EU2 plus 1 plus EU1. Tabhi chalega. If you don't want to remember this, at least remember this. It's quite symmetrical thing. 2 minus 1 upon 2 minus 1. Which is what? Minus of E. Very easy part. You can note down this. Now, look at another heavy and light object collision. This is Earth. and you drop a ball from some height h. If you drop a ball from some height h, then again you can see that what is Earth? A very heavy object. Ball as compared to Earth, is extremely light, and therefore whatever we have done, we can use in this type of collision also. This ball is dropped from rest. This ball is dropped from rest. It comes and collides with Earth and bounces back. Question is that coefficient of restitution is E. Question is that coefficient of restitution is E, and we need to find two things. Write down those two things. First is find out velocity of the ball just after collision. Velocity of the ball just after collision. And the second part, find out velocity of the, in the second part, find out height reached by the ball after first collision. What do I mean by first collision? This ball, when you drop it, it will collide with Earth, it will bounce back. First collision. It goes up, comes back down, second collision. Goes up, comes back down, third collision. It will keep on colliding, that will keep on bouncing. We are interested in things after first bounce. And then we'll see for other bounces. But right now the question is, find out velocity of the ball just after it hits the Earth, and then after first bounce, to what height this ball reaches. Note down this and note down this question, try to answer it, and then we'll see the solution. Note down this much. Let's see how we handle this question. When you say heavy object like Earth, that means U1. 1 is for heavy, and therefore U1 in this question is what? 0. If you are using this formula, remember that 2 is for light object and 1 is for the heavy object. For us, Earth is not moving, U1 is 0, and this ball is at rest. Once I say ball is at rest, some people, they take U2 as what? 0. 2 is the velocity of light object. U initial. They go for U2 as what? 0. But no. What do you mean by U1, U2, V1 and V2? When you say U1 and U2, these are velocities just before impact. And V1 and V2, these are velocities just after. And therefore, this rest should not be used as U2. Instead, everybody knows that when an object falls from rest under gravity, then just before it hits the ground, its velocity is given by root over 2gh. I hope you remember this formula, root 2gh. This root 2gh is the velocity of the ball just before it hits the ground. If I say u2 and take minus of root 2gs, negative sign for downward signs. Let's put these values in this. Minus of e u2. What is u2? Minus of root 2gh. Minus of root 2gh. u1 being 0. This part is what? 0. And therefore, when this ball it bounces back, its velocity is e times root over 2gh. Negative of negative is what? Positive. E times root 2gh. This is the first part of the question. What is the velocity of ball after first bounce? This is velocity of the ball after first bounce or first impact. Now, second part of question says that with this velocity e times root 2gh, to what height ultimately this ball can move to? इसके लिए फिर से यही फॉर्मेट हमारा क्या फॉर्मेट है? हर आदमी को पता है कि अगर आप किसी चीज को v से थ्रो करते हो और ये चीज h हाइट तक जाती है, remember at height h it should be at rest, then v is given by what? Root over 2gh. If you throw an object with v and it goes to height h and ultimately comes to rest, then v is what? Root over 2gh. हमारे केस में जो बॉल है वो ऊपर की तरफ जा रही है किस वेलोसिटी से? e times root 2gh. Velocity of the ball is e times root over 2gh, and if it goes to height h1 after the first bounce, if it goes to what height? h1 and ultimately comes at rest, then you know that this e times root 2gh should be equal to what? Root over 2g multiplied by what? h. Which h? This h, which is what? h1. Cancel 2g and 2g and you got h1 as e square multiplied by what? h. This is the height of the ball after first bounce. होपफुली समझ में आ गया होगा किस तरह से हमने इस चीज को हैंडल किया हुआ है. नोट डाउन एवरीथिंग.